Welcome back guys, Jimmy Jules here again with another CREY prop tutorial. In today's episode, we'll be going over two props, the wireless transmitter and the wireless receiver. What these props will do is it will transmit a signal that you send into the wireless transmitter to the wireless receiver. We'll of course be going through some use cases with how we might use these props in some of our examples. On the left hand side we have our wireless transmitter and our wireless transmitter's settings page. We can choose the name of our wireless transmitter. For example, if we call this transmitter 1, we can then go into the wireless receiver's settings menu and choose that wireless transmitter from the drop-down box at the top. Once we have our wireless transmitter and receiver with the same transmitter name, they'll be connected together. Now that they are connected, we can send signals between the two without wires. To show you how these props work at their most basic level, we'll go through sending a simple signal from one prop to the other. We'll plug port 1 from our selector, which is on by default, into the signal in on our wireless transmitter. Then from our receiver, we'll plug the signal out into a number displayer's number input, and we can see this number displayer changes to a 1, which means that our wireless transmitter is transmitting the signal from this selector over to the receiver and into the number displayer. It doesn't matter where these props are in your game, they will still wirelessly transmit between the two locations. The transmitter and receiver can do more than just send ones and zeros though. They can also send percentages of a signal, and we can send signals of more than one as well. So how might we use this in a game? Transmitters and receivers are most useful when you have props that you'll be making copies of or that you'll be emitting. We'll go through an example of how they might make our lives easier with copying props right now. Let's say for example you wanted to give your player the control of a brightness of a light in your game. To give our player control of this light, we've just got two input triggers here, each assigned to a different key. The first one is assigned to the number 1 key on the keyboard, and the second one is assigned to number 2. These are just plugged into the next and previous ports on our selector respectively. Basically what this means is when the player presses the 1 key, it's going to increase the number of the port on our selector. When they press 2, it's going to decrease it. We're then using this currently selected output, which will tell us the number of the selector that's currently selected, which we're changing with our next and previous inputs, and we're pumping this into a number displayer. So our number displayer is going to tell us which port our selector is currently on, and we can also use this currently selected output and plug that into the intensity of the light. This way we'll be able to control the intensity with our 1 and 2 keys on the keyboard. So we have our light on the ground here, and we can't really see it at the moment because the intensity is very low. You can see our number 1 at the top of the screen there, which is indicating that our selector is on port 1 currently. If we increase the selector port with our number 1 key, that will also increase the intensity of the light. If we press number 2, it will decrease it again. Now let's say for example we were making a large scale game where you needed 50 of these. If you were to do it manually, you'd copy each of the lights 50 times, and you'd need to plug our selector, and we'd need to plug our currently selected port from our selector into each of the light's intensity ports. This would be quite time consuming. So how can our wireless transmitter and receiver help with this? At the moment we have one centralized thing controlling the brightness of our lights, which is these two input triggers and the selector. Rather than manually plugging in each of these lights into our selector, we can simply transmit the selector's value and then receive that value at the light and copy this around. I'll show you what I mean. So rather than plugging our selector's currently selected output into the light, we'll instead plug it into the wireless transmitter. I've named this wireless transmitter player controlled because this is a transmitter that the player is controlling with their input triggers. We'll then grab our wireless receiver and we'll make sure this is on the correct transmitter, and we're going to plug the signal out port into our intensity instead. Then just to make things easy, we're going to use a box it up box to box these two props. Like so. So now that we have our neat little box it up box, we can copy this around a bunch of times, and without any modification to the props inside, these lights will simply be controllable by the player because they're all receiving their transmitter input. So you can see I've just copied that a bunch of times. You can imagine if we were making a larger game, this would be more effective. And if we jump into play mode and give this a test, if I press the 1 key on the keyboard to increase the brightness, you can see all of the lights change and they're not plugged into the selector. This can both save a lot of time and also save a lot of mess so you don't have as many wires around. Next, we'll go through how to emit an object and have it hold a value that it receives wirelessly. In this example here, we have a light spawning, and as it spawns, it receives a brightness signal from a transmitter. It then saves that value and sets the light to that brightness. After this example, we'll go through how to make a coin that spawns with a random coin value, so you get a different value of coins each coin you pick up. This light example is slightly easier to understand, so we'll go through this one first, and then we'll go over to the coins. At its most basic, this transmitter is transmitting a random number that's generated by our randomizer, and that number is controlling the brightness or the intensity of our light. You can see here, because we're in edit mode, this light is continuously changing brightness. The slightly trickier part is being able to receive the number once the item is spawned, and then save that initial number that our receiver receives, so we can keep the light at a static random brightness. To produce our random number, I have a timer that's resetting itself every 0.01 seconds, so it's just producing a very quick pulse. This pulse from our timer is then going into the input and the randomized ports for our randomizer with 9 ports. So this means every 0.01 seconds is going to produce a new random number between 1 and 9. We're then using this random number from our randomizer to set a port on our selector so that we can use the currently selected output to grab that number. This is just a cheaper way of doing it than having 9 equal to calculators. We're then sending our random number from our currently selected port into the transmitter. We're then receiving this number, setting that number on our other selector, and then this is powering our light. So we have our signal that's being sent out here. Now to receive the signal, this looks a little bit complex, but it's really very simple. We have our wireless receiver, which is receiving the signal from our random wireless transmitter. We then have this transmitter plugged into 8 equal to calculators, and these are just checking if the value is equal to 2, or equal to 3, or equal to 4, and so on, all the way up to 9. We don't need an equal to 1 calculator because the selector will be on port 1 by default anyway. We then have these calculators plugged into their respective ports on the selector. So you can see here our equal to 2 calculator is plugged into port 2 of our selector, and our equal to 4 calculator is plugged into port 4, and so on. So this will immediately receive the signal from our random transmitter, and then set the selector to the respective port. So for example, if our random number is 8, our equal to 8 calculator will be activated and set our selector to port 8. Then this number 8 will be saved, and we can use this from our currently selected port. The trouble is, if this is all we have, our selector will be continuously changing ports and changing the brightness of our light, like it is in edit mode here. So what we need to do is, once our selector has been set by our wireless receiver, we need to destroy all of the props that are setting it in the first place. So this means once the selector has been set to a number, we're going to destroy the receiver and all the calculators to both save a bit of memory and to store our number permanently in the selector. I'll go through how we do this now. We have our box it up box here, and I'm going to select all of these calculators, as well as the wireless receiver. I'm going to press the B shortcut and then select the box it up box. Now we'll use a destroyer. To activate this destroyer, we're going to use a timer set to 0.01 seconds, and we're going to use the timer finish pulse to activate the destroy input on the destroyer. We're destroying the target, so what we need to do is press the T shortcut over the destroyer, and then target the box it up box. We're also going to box this destroyer up in the box as well. So that way, if we close it up, you shouldn't see anything except for the selector and your light, and all this calculator is doing is doubling the selector's value. And then all of these props are going to be destroyed, leaving our selector with its set number. We have another box here, and we're going to contain all of the props in this box, so the light, and I'm going to box this box also up into this parent box. Now back at our transmitting station, we have our pulsing timer, and I'm also going to use this to activate the spawn input on a spawner that's targeting the box that we just made with our random brightness light. So this just means it's going to continuously spawn this box. So you can see, as the light is spawned, the wireless receiver receives that random signal from the transmitter. It then saves that value into the selector and then sends that onto the light to adjust the brightness. Now we can't really see exactly what's going on here, so I'm going to add a primitive cone into the box with our props here. So I've now got this cone inside our box. Now when we look with this box closed, all that we really have in this parent box is the selector, the calculator, and the light. You can imagine in comparison, this box will be quite expensive with regards to performance, So we're saving a lot of memory by deleting this box or destroying it once we're finished with the props inside. You can see now that we have this primitive cone also inside the box. As soon as the light is spawned, the cone is there for 0.1 of a second, and then it gets destroyed along with all the props inside that box as well. So all that we're left with in the game is a selector, a calculator, and a light. This just means that we're not having unnecessary props in our game and bogging down performance. Now that we've seen this setup with a light, we'll go through a very similar setup with how to make a coin that gives you a random number of coins when you pick it up. We've got a quick coin spawning setup over here that's going to spawn 10 coins and then stop. These coins are very similar to the lights that we were spawning in our previous example. I've copied over the box that's destroying itself into this setup as well. You can see this box here with all the same props. And we're again saving this value in our selector, but rather than sending that signal to a light to adjust the brightness, we're sending this signal to a variable modifier to adjust a value. We're changing the modification amount on our variable modifier, and we're going to add that random amount to our currency whenever we pick up the coin. This variable modifier is being powered by a sensor, so it detects when the player is near and then activates our variable modifier. This sensor also activates a destroyer, which destroys the box entirely so the coin disappears. This setup is very similar to the lights, but we get a little more function out of it as well. So this coin setup here will give you a coin value from anywhere between 1 and 9 coins. You can see from these couple of examples here that wireless transmitters and receivers really excel when they're being used on an emitted object to receive data. Without the transmitter and the receiver, this simply wouldn't be possible. Whether you use them for simply tidying up wires, for making copying and pasting props easier, or for receiving values on an emitted object, the transmitter and receiver are very capable props, and I can't wait to see what you guys come up with for them. Anyway guys, that's just about all the examples that we have for today. If you have any questions or just have something to say, definitely leave a comment. This has been Jimmy Jules, and I'll see you in the next one.